In this lesson, we're going to focus on being able to find the confidence interval of a single mean, which also means we'll be dealing with the margin of error for this, which we get from our sample or standard error. So those will be the main things that we'll be looking at here. Now, remember from the last lesson that our standard error of x bar is sigma, the population standard deviation, over the square root of n. Also remember your confidence interval. In general, it's your statistic, your mean or your proportion from your sample, plus and minus z star times your standard error. But remember, when we are replacing our population standard deviation, which we typically don't know, with S, our sample standard deviation, we get a t-distribution instead of a normal distribution. So it ends up being our statistic, our mean or our proportion, plus or minus t star times our standard error. So more specifically, it's your x bar, because we're dealing with means, plus or minus t star times this fraction of s, your standard deviation from your sample, over the square root of your sample size. In other words, the stuff after the plus or minus ends up being your margin of error. So let's go ahead and try to do a confidence interval for this situation. So pause the video, read through it, and then if you want, try to do it on your own, or you can play the video and I'll walk you through it. So we have our sample of 50. We have our mean length of 3.1 millimeters and our standard deviation of 0.72 millimeters. And our confidence level is going to be 90%. So what we can do is we can start out with our basic formula, take our statistic plus or minus z star times your standard error. Now our degrees of freedom that's going to help us find our t star is n minus 1. It's your sample size, which was 50 minus 1. And we end up getting this. So how do we get that? Let me show you. So we'll go to stat key, we'll go down to theoretical distributions, we'll hit T for our T distribution. We'll type in our degrees of freedom, which we said was 49. We'll do our two-tail because we're doing a 90% confidence interval, so I'll click in the center box, hit 0.9 for 90%, and these numbers down here in the bottom are the T star, so 1.677. So that's how we got this 1.677. So now we can go ahead and plug stuff into our formula. We have our mean, which was on the previous slide, our t star that we just had, our standard deviation of our sample from the previous slide, our sample size of 50. Then what's after the plus and minus, we can type all that into our calculator and it gives us about 0.17. So our confidence interval is going to be 3.1 plus or minus 0.17. So if you subtract those two, you get this first number. If you add these two, you get the second number. We would say we are 90% confident that the average length of our Gribbles is between 2.93 and 3.27 millimeters. Once again, I had mentioned the stuff that's after the plus or minus is your margin of error. Well, just like we've done in the past, we could go ahead and do some algebra for this, and we could solve it for n. I'm not going to go through all that, but it ends up giving you this right here. Now, n is your sample size. So in other words, if you have a certain margin of sorry about that, a certain margin of error, we can work backwards to figure out what size sample do we need to have. So here's our formula, but we need to know what t star is so that we can figure out n. Now, a lot of times we use z star instead of t star because they're going to be pretty close to the same. So that changes it up here from a t star to a z star. We also need to know s. Well, we could estimate s either from a previous study or a similar population. We could take a small pre-sample to estimate what S is, or we could do the max minus the min, which is our range, and divide that by 4, and that will give us an approximation of S. If none of that really works, then we can make a reasonable guess.